Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video, we'll be discussing about question number 13, NEET Physics paper 2015. Let us solve, student, the number 13 of this paper. A, B, C are voltmeters of resistance R, 1.5 R and 3 R respectively. So there are 3 voltmeters connected here, A, B, C, having resistance. So I'll just draw a diagram for you. This is a voltmeter A whose resistance is R. There are 2 other voltmeters B and C, and they are in parallel and this is in series. This point is X and this point is given as Y, as shown in figure. It is having resistance R, it is having resistance 1.5 R, and this is having resistance 3 R, as shown in figure. When some potential difference is applied across X and Y, so between X and Y, if I apply a potential difference, so let us apply the potential difference. Okay, suppose the potential difference is V. Now the voltmeter reads VA, VV. So if I apply a potential difference, so obviously that will be reading, current will flow and it will read some values. Here the reading is VA, here the reading is VB, and here the reading is VC. VA, VB, VC are respectively the readings of those voltmeters. Then you have to see how these VA, VB, VC are related, whether these two are equal and not equal to CC, or they are not equal to each other, or all of them are equal or so. Now we have to understand that, so instead of thinking about the voltmeter, we have to think about basically the resistance actually. If I have a resistance like R here, 1.5 R here and 3 R here, then how the current will flow, and the whatever current that flows through this, suppose the current is I, the same current will flow through this here, and there will be division of current here at this junction. Some part of the current will flow through B and the remaining will flow through C out of this I. Suppose the current here is I1 and the current that is flowing here through is I2, and these two will meet here and will make current I. Now our aim is to find the potential difference, what voltage this will read. In a shortcut method I can tell you, or in details also I can tell you, but first let us discuss in detail what is the value of VA, VV and VC and how they are related. So if I want to find the value of I, first of all I have to think of another thing. Let me solve it by shortcut method, because our aim is to first solve the question, not to take more time in experimenting things. This is 1.5 R and this is 3 R. What is the total resistance we find? If I know the total resistance of these two in parallel and then with series with A, then I know the total resistance. If I know the total resistance, then I will have the idea that whatever current flows, the same current will flow through this, and how this resistance is related to this resistance. First of all, that division I will have. Suppose that this is R and this comes out to be, suppose that this comes out to be 2R, suppose. Then we divide the voltage in the ratio R here to R here. In series, the more the resistance, more is the voltage drop in the direct ratio. that is V is proportional to R. So accordingly I can divide the voltage, and whatever voltage flows through this here, what voltage drop is here, the remaining will be the voltage drop across the combination of the two, and because they are in parallel, so their voltages will be same. So what I have to say is, see here, first let me find the effective resistance of 1.5 R and 3 R. Okay, here 1.5 R and here 3 R. So what is the effective resistance of this combination? This will become, this is a product by sum, the effective resistance for this combination is 4.5 R square divided by 4.5 R. This comes out to be R. So, and along with this we have A whose resistance is R, and this combination will have a resistance also R. This combination is also having resistance R, and this is also having resistance R, and this is connected across a voltage V. Now how this V is divided? This will be equally divided, because resistance is same, voltage division will be same. So in the first A voltmeter, the potential, the reading it will make is V over 2. Out of V it will be equally divided. Here also it is V over 2. This is a potential drop. So V over 2 here, V over 2 here. So because that this here it is V over 2, and here also it is V over 2, V over 2. But because these two are in parallel, so voltage drop here and here will be same, because when in parallel combinations the same voltage will be dropped here and here. So here also it will be V over 2. That means in all three the voltages are same. So therefore option number 3 is correct. If I want to solve in another way, I can solve that way also. I'll just tell you, if you don't convince yourself that this is V by 2, V by 2, then I will just help you understand that. This is 1.5 R and this is 3 R. Its resistance is double this resistance. Okay, its resistance is double this resistance. And how much current is flowing through this? Suppose the current is I. Here, how much current will flow through this one? Current flowing through this branch will be, let me draw here and solve this for you. This is 1.5 R resistance, and here 3 R resistance, and suppose the current coming is I. How much current will flow through this? The current that is flowing through this here, I'll write I1 equals to 3 R, the resistance of this branch. So I1 is 3 R divided by total resistance, that is 4.5 R, into the current. R cancels, and this is 30 over 45 I, that is I, 2 by 3 I. So I1 is 2 by 3 I. So I1 I write 2 by 3 I. The remaining current will flow through this, then that is 1 by 3 I. The total is I. If 2 by 3 I is flowing through this, then the voltage drop across this current into resistance from Ohm's law, the voltage drop will be given by the voltage drop across B. This is B, this is C. Voltage drop across B equals to current that is flowing, that is 2 by 3 I, into resistance is 3 by 2 R, because 1.5 is 3 by 2 R. So if I see this, you can see that these three, 2 will cancel out, and this is I into R. Okay. And what about this? The voltage drop across this one, that is VC, equals to current, that is I over 3 into the resistance is 3R. This will cancel. This is I into R. So again it is IR. Here also IR. Here also I am getting IR. So it is clear that VC is VV. And what about the first one? The first one, I am taking current I flowing through the main circuit. This I is coming from A. Passing through A, this I goes to the other two. I is going through A and the through. So what about the voltage drop across A? The current that is flowing, that is I, and the resistance that is given, which is R. So this will be R. If you see all these three values, VA is IR, VV is also IR, VC is also IR. So from these three, we conclude that as I told you, the voltage drop across each voltmeter or the voltmeter reading will be same. Okay, thank you.